In this video, I'm going to look at a couple more examples of finding volumes of solids of revolution. In this case, I'm going to have the region bounded by this equation. So y equals negative x minus 2 quantity squared plus 1. So it's bounded by that and the x-axis, and we're going to rotate that region about the y-axis. So this is sort of written in a weird form, but actually that's nice. This is a quadratic function. If we multiplied this out, I'd have an x squared as my highest power. Written in this form, this is standard form, so it's pretty easy to see what the vertex of this parabola is. That's a minus here. It's going to be opening down. This is going to be negative then, unless it's 0. And the only time it could be 0 is if I let x equal 2. So if x is 2, then I get 0 squared, and negative 0 is 0, so I get y equals 1. If x is anything other than 2, then I get something squared that's going to be positive, but then it's going to get multiplied by a negative. So I'm going to have a negative number plus 1, that's going to be less than 1. So the maximum of this function is going to occur when x is 2, and then I'm going to get a value of y, which is 1. That's the vertex. So the vertex is at 2, 1. As far as then this, we want to know where this parabola is bounded with the x-axis. The x-axis is the line, of course, y equals 0. So if I set my parabola equal to 0, that's going to find the x-intercepts where it crosses the x-axis. So we would get negative x minus 2 quantity squared plus 1 equals 0. I can move that quantity to the other side to get rid of the negative. Then I can take the square root as long as I put in plus or minus. So plus or minus 1, square root of 1 would be x minus 2. That tells me that x minus 2 is plus or minus 1. So x is either 2 plus 1, which is 3, or x equals 2 minus 1, which is 1. So we get 1, 0, and 3, 0. And so my parabola is opening downward, but I only care about this portion of it in that first quadrant. So it's bounded by the parabola and bounded by the x-axis. So that's my region. Now, with this, you might say, well, how should I decide vertical or horizontal rectangles? Well, I need to decide whether I want to do shells or whether I want to do discs or washers. Well, no, not really. If you try to do horizontal here, you'd have to be going like this, but now the left and the right endpoints of that rectangle are both on the same function. It wouldn't be impossible to do this, but what I'd have to do, I'd have to take this equation and solve it for x, because realize that to find the length of this rectangle, that's a horizontal distance. So I would have to take the x-coordinate on the right minus the x-coordinate on the left. I would have to solve this equation for x. One would be a positive square root, one would be a negative square root, and those would be the two sides. And although that's possible, for me it's not desirable. It's much better if I would take a vertical rectangle, because then the top is always along the parabola and the bottom is always along the x-axis, which is y equals 0. So I decide to do vertical rectangles regardless of how I'm rotating this region. Now I say, okay, I'm rotating around the y-axis, so that's going this way. Well, if I'm rotating around the y-axis, then, my rectangle will be over here, and I'm going to get one of those cylindrical shells, right? That's the type of shape I'm going to get when I rotate. So I'm going to have to use the shell method. So for the shell method, the other thing I'm going to need is to recognize that this is going to be a value delta x then, right? That's the little rectangle. So the volume of the shell is going to be 2 pi r, the circumference, times the height times the thickness, delta x. To find the radius, well, x is going to keep track of where that rectangle is. The radius is going to be that distance here. All the way over to the left is x equals 0. For my height, that's going to be this here. The top is this y equals negative x minus 2 squared plus 1, and the bottom is y equals 0. So the volume of my shell is 2 pi. My radius will be x minus 0. The height will be negative x minus 2 quantity squared plus 1. Minus 0, and then delta x. So I'm going to get 2 pi times x. Okay, so when I square this, it's going to be x squared minus 4x plus 4. But then I'm going to have to distribute a negative. So negative x squared, it'll be minus 4x, so that'll become plus 4x. It would be plus 4, so that'll be minus 4, and then I have the plus 1. You can do that by yourselves off to the side or on scratch paper if you need to. So I'm going to get negative x squared plus 4x minus 3. And if I multiply the x in, negative x cubed plus 4x squared minus 3x delta x. So my overall volume, then I'm going to have my 2 pi I can factor out. My integral here is with respect to x, right? I've got a little delta x here. All this stuff is x. So my x coordinate starts here on the left at x equals 1, and it ends up on the right at x equals 3. So I've got negative x cubed plus 4x squared minus 3x dx. So I take the antiderivative. X to the third, I go up 1, x to the fourth, divide by the new exponent. Go up 1, 4x to the third, divide by 3. Go up 1, 3x squared, divide by 2, and that's going between 1 and 3. So I plug in 3. Negative 3 to the fourth over 4 plus 4 times 3 to the third over 3 minus 3 times 3 squared over 2 minus, I plug in 1, negative 1 to the fourth over 4 plus 4 times 1 to the third over 3 minus 3 times 1 to the second over 2. So negative 81 over 4. 4 times 27, 108 over 3. 3 times 9, 27 over 2. Be careful now here with this minus. We need to distribute that to all the parts here. So negative 1 to the fourth. It's not negative 1 in parentheses. It's 1 to the fourth with a negative in front. So that's going to be negative 1/4, but then there's the minus that gets distributed. So that's going to be plus 1/4. Here I'm going to get plus 4/3, but the minus out there then makes it minus 4/3. Here I'm going to get minus 3/2, but the minus outside makes it plus 3/2. All right. Oh, let's see. To make this easier, let's just change everything to a common denominator of 12. So times 3, times 4, times 6 times 3 times 4 times 6. You could have also combined like terms first if you want. I just feel like doing it this way, getting it all over at once. So negative 243 over 12 plus 432 over 12 minus 162 over 12 plus 3 over 12 minus 16 over 12 plus 18 over 12. And if you put all this together, you can do it different ways. You could do all the positives and then subtract off the negatives. You could, do this a variety of ways. If you end up looking at that, we end up getting 32 over 12. So that would be 32 pi over 6 if we cancel the 2 and the 12, which would be a nice volume of just 16 pi over 3. Okay, now I'm going to do this same problem, but we're going to rotate about the x-axis instead of about the y-axis. And we're going to want to leave the rectangles going the same way, though, because of what we talked about earlier. So if I rotate about the x-axis, then this little rectangle now isn't going to be parallel to the axis of rotation. It's going to be perpendicular. I'm going to get a disk. One thing I'm going to have to do in the middle of this problem is I'm going to have to do a computation that's a little bit involved, and I don't want to do that in the middle of the problem. So I'm going to do it here to the side. You could do it off on scratch paper in the middle of the problem if you wanted, but we're going to have to take this quantity, negative x squared plus 4x minus 3. That showed up in that last problem, right? That's what happened when I multiplied out that parabola. And I'm going to have to take this and square it. So I'm going to have negative x squared plus 4x minus 3 times negative x squared plus 4x minus 3. And so if I start, I can multiply that negative x squared times all these parts over here. So negative x squared times negative x squared is positive x to the 4th. Negative x squared times positive 4x is negative 4x to the 3rd. Negative x squared times negative 3 is plus 3x squared. Okay, then I can do the plus 4x. Multiply that times all three terms. So positive 4x times negative x squared is negative 4x cubed. Positive 4x times positive 4x is positive 16x squared. Positive 4x times negative 3 is negative 12x. And then finally here, I can just multiply the negative 3. Negative 3 times negative x squared is positive 3x squared. Negative 3 times positive 4x is negative 12x. Negative 3 times negative 3 is positive 9. And so when all the smoke clears, we get x to the 4th minus 8x to the 3rd plus 22x squared minus 24x plus 9. And I'm just going to need that result when I do this problem. So at one point I'm just going to plop that in, and that's where it's going to come from. Okay. So here's this setup, just like I talked about. We've got this same region, so I don't have to reinvent the wheel here. I know what this is going to look like. I'm going to have my vertex at 2, 1. It's going to intersect the x-axis at 1 and 3. So I've got this nice region here. The difference is now I'm going to rotate about the x-axis. That's what the problem says. I'm still going to want to use a vertical rectangle, because a horizontal rectangle, the right and the left endpoints would be on the same function. with this vertical rectangle, my top is along the parabola and the bottom is along the x-axis, which is y equals 0. So when I rotate this now, since it's perpendicular to the axis of rotation, it's going to be a disk or a washer. In this case, the bottom of the rectangle stays along the axis of rotation, so I don't have an inner radius here. So it's really just a disk. I don't get a washer here. And so the volume of the disk is just the area of the cross-section, pi r squared, times the thickness, and this thickness is going to be delta x. My radius is going to have to be this distance here. So that's a vertical distance, so the top is this parabola, and the bottom is just y equals 0. So the volume of this disk so I take the radius is this top, which is here, minus the bottom, which is here. Okay, now we multiplied this out in the last problem. We got negative x squared plus 4x minus 3, and that's what I multiplied out on the last page. So this is where I get x to the 4th minus 8x cubed plus 22x squared minus 24x plus 9 delta x. So my overall volume, I'm going to add up all of those disks. That's going to take x values from 1 to 3. I'm going to go ahead and factor out the pi. So I've got x to the 4th minus 8x cubed plus 22x squared minus 24x plus 9 dx. So I take the antiderivative. X to the 4th becomes x to the 5th, divide by 5. 8x to the 3rd becomes 8x to the 4th, and then divide by 4. 22x squared becomes 22x cubed, and then I divide by 3. 24x becomes 24x squared, and then I divide by 2. And then I get 9x, and that has to be evaluated between 1 and 3. So I can simplify a couple of those fractions. I get x to the 5th over 5 minus 2x to the 4th plus 22x cubed over 3 minus 12x squared plus 9x, evaluated between 1 and 3. So I plug in the 3 to the 5th over 5 minus 2 times 3 to the 4th plus 22 times 3 to the 3rd over 3 minus 12 times 3 squared plus 9 times 3 minus, now I plug in 1, so 1 to the 5th over 5 minus 2 times 1 to the 4th plus 22 times 1 to the third over 3 minus 12 times 1 squared plus 9 times 1, like that. So we just have to be really careful with my signs and everything here. So 3 to the 5th, 243 over 5. 2 times 81 minus 162. 22 times 3 cubed is 27. That ends up being 594. 12 times 9 is 108. 9 times 3 is 27. Be careful with your negative here to distribute. So we get minus 1/5 plus 2 minus 22 thirds plus 12 minus 9. All right, so what do we have here? You know, you've got a lot of choices as far as how you approach this. I'll go ahead and put like denominators together right now. So 243 over 5 minus 1 over 5 would be 242 over 5. I've got 594 over 3 minus 22 over 3, so that's plus 572 over 3, and the rest are integers. So I've got negative 162, negative 108, positive 27, positive 2, positive 12, negative 9. If I put all that together, I get minus 238. You want to check me on that, of course. So I'm going to convert everything to 15. So I'll multiply top and bottom by 3. So that gives me 726 over 15. I'm going to multiply here by 5, top and bottom. That gives me 3570 over 15. Here I think of that as 238 over 1. If I multiply top and bottom by 15, oops, what did I, oh yeah. If I do top and bottom, wait, I got off. I have things in a different order on my piece of paper. So 572 over 3. If I multiply top and bottom by 5, that gives me plus 2860 over 15. Sorry about that. And then that over 1. I multiply top and bottom by 15. 238 times 15 is 3570. And when all this clears, I add those together and I subtract, and I get 16 pi over 15 for the volume of that region. So in these last two examples, we didn't have much of a choice for how we set up our rectangle. So whether I used the cylinder method or the disc method was determined by where I was rotating. And we really didn't control that much. So it's important that we be able to do both methods. Both methods are equally good in theory. In practice, it sort of depends how you have to set up your rectangles.